In this video, we're going to talk about basic properties of waves that are incredibly important to understand. And if you'll notice, I have both my types of waves. I have my transverse wave at the top and I have my longitudinal wave at the bottom. The transverse wave at the top is going to have the most amount of properties. And the basic properties that we have if we're looking at our transverse wave. First of all, it's important to understand that this middle line that we have here, this is just our medium. So what we're going to be looking at here is just the propagation of our different particles from the medium. So the very top points that we have, these are called crests. So the very top point here are crests. The very bottom points that we have are troughs. So in this case, we have two crests and we have two troughs. The next thing that we want to take a look at is the height of the wave. And the height of the wave is just the amplitude. So the amplitude of the wave. Now, typically the amplitude is going to be measured in meters, but it could be measured in other things as well. It really depends on what we're looking at with the wave. The most important thing to understand then is the length of the wave. Now the length of the wave is actually just called the wavelength. And the wavelength itself can be defined as from one part of a wave to the next successive part of the wave. So if we're looking at the trough, let's just say, from the trough to the next trough, this is the wavelength. And the wavelength is called the variable lambda. That's L-A-M-B-D-A. It's a Greek letter, lambda, and the unit is in meters. So the wavelength itself is actually just a distance. That's in meters. So it's a trough to a trough. It could also be from crest to crest. It doesn't have to necessarily be a trough. It could also be from where the wave is actually starting, let's say upwards on the medium there, to where the wave is upwards again. So from this point to this point is also the wavelength. So there's lots of different ways to actually measure the wavelength, but it's important to understand what the wavelength actually is, and that it's not just, if you look here, a lot of people think it's just the one part of the wave, but it's the entire wave itself. So it's where it's starting to where it's starting again. So the entire length of the wave is the wavelength. So the crest, the trough, the amplitude, and the wavelength are the most basic parts of our transverse wave. Now when we're looking at our longitudinal wave, the key thing that we're going to have is our wavelength. Crests and troughs, they don't really occur the same way with a longitudinal wave as they would with our transverse wave. We're going to have what we call compressions and rarefactions when we're talking about sound waves specifically, but that's due more to the air pressure that we have. So it's not really a crest and a trough, but it's related to that. So if you take a look, we have on our longitudinal wave, we have an area that's pretty compressed, an area that's pretty far apart. Now, if we wanted to figure out the wavelength, it's going to be from the compressed part to the compressed part. So that would be our wavelength. But it could also be from where it's pretty far apart to, again, where it's pretty far apart. So that also could be our wavelength. And really anywhere in between. But those are probably the easiest spots to measure with a longitudinal wave. So that's all there really is with the longitudinal wave to worry about for the time being. There's a little bit more to worry about when you're looking at our transverse wave.